Yeah, dear students, I welcome you all for the online learning platform for the course Warehousing Automation. So today in this particular presentation, we'll go ahead with the next chapter in Unit 3, Planning and Implementation, and the chapter name what we are going to learn today is ASRS. Okay, so ASRS is an acronym. We'll learn everything in this presentation. So ASRS is nothing but automatic storage and retrieval system. Okay, so how it is going to work, what all are the different mechanisms, elements, components available in it, and what all are the potential benefits we can reap out of it will be the discussions in this particular presentation. So now without much delay, we'll just go for the further discussions. Yeah. So, what's the basic understanding in a warehouse is? So, basically, it is going to be in a traditional warehouse, humans, that is manual, everything is going to occur. That is manual intuition or experience plays a very crucial role. And the another important aspect here is they are the one who is going to take care of the supply and demand, irrespective to the consumption. They are the one who does all these tasks in a warehouse. So the manual arrangement is always tedious to understand and to automate. Why? Because of intuition, what they do is they don't allocate a proper place for it. There is a component by name A. So that will be maybe it is a one which is going to be frequently used irrespective to the size and other things. They keep in the nearby place. Okay, under their own intuition, under their own experience, they come out with some sort of plans like this. And some cases it may not be apt, it may not be proper to do so. Okay, so this is number one. And second thing is, when you want to automate, definitely there should be some sort of scientific guideline should be there. So another reason for such difficulties also the same. Okay, so now we'll see how to go ahead or to solve this particular problem. So this is what the traditional practice is all about. Okay, so traditionally you can see this is the conventional packing where manually we go and do, and this is what ASRS, automatic storage and retrieval system, is going to look like. Okay, these all are the two distinguished factors which we need to consider. So before we go for the further understanding, we'll just go ahead with one particular video presentation to know how it works actually. Okay, so with that, with this understanding, we will go for the next slide. Okay. Related to machining, we will be using a good amount of tools. So arranging them in a proper case is going to be quite difficult. You have a carousel, you have a bin, put all the tools into it. Say for example, some 20 spanners you have put into that particular carousel in the bin. Now you wanted to have one particular spanner. How to retrieve that particular spanner alone? Is it going to be easiest task? Means definitely it is not going to be so. Okay, so that is the case. Even ASRS plays a role, not only with respect to warehousing cases, even in manufacturing cases, even in pharmaceutical cases. You have got good amount of tablets, all those things put into boxes. So which particular tablet is having in or positioned in which particular case. So likewise, irrespective to the field of application, wherever you have got some sort of distribution activity comes into picture, we just prefer ASRS category. Okay, so that is the first understanding what you should have. So basically, we use ASRS for the case of effective, efficient and securely storing items. Not only to store items, we wanted to compactly arrange everything, not in an haphazard case. So it has to be properly arranged at the same case. We wanted it to be properly arranged. Okay, so what it does is it allows the user to easily and quickly retrieve items when needed. Whenever needed, not only for the case of picking and packing, any cases you wanted to have a tool, yes, we go ahead like that. And there are good amount of companies are there who involved in this ASRS manufacturing activity. So they do self-contained GTP, that is goods to person automated storage and retrieval system. There are good amount of companies involved in this particular business. So here what is the thing is, these technologies handle different volumes. They are not confined only to say some M numbers or something like that. Okay. So theoretically speaking, they are very good to handle different volumes, types and velocities of non-palletized inventory at variable speeds to accommodate varying throughput demands. So now the term, a new term where we are coming across is non-palletized inventory. See, palletized inventory and non-palletized inventory is an interesting topic of discussion that we'll be making in the some other units. If I'm not wrong, unit 4 is the case where we are going to talk about packing. So there we'll be discussing a lot in this regard. So palletizing means stacking one over the above. Okay, so we'll have one carton or a one box, so above which we'll be having another. Likewise, we can stack some, theoretically speaking, some good numbers we can stack. But coming for non-palletized means they are not in a properly packed condition. They might be, though they are in packed condition, they will not be similar. They will not have all sorts of similarities. So non-palletized inventory is of that nature, and often we can't give an assurance that always we'll have products which are in the packed condition. Some cases without packing, or though they are in packed condition, they may not be having similar shape, similar size. So likewise we might be having difficulties in this regard. So ASRS system is highly capable even to handle such non-palletized inventory without proper packing or different packings with different sizes. So either cases, that is with packing, without packing, or irrespective to the sizes, ASRS is capable to handle. So what all are the other names? We should know the other names for ASRS. So automated storage and retrieval system is the actual acronym, that is abbreviation. So it is also called as dynamic storage systems, high density storage and retrieval systems, goods to person picking technology. So GTP picking technology, the other term, high density storage and retrieval systems number 2, and number 3 dynamic storage systems. So these all are the different names by which this ASRS system is also called as. So now we'll get into the objectives. So what all are the objectives of this ASRS? First thing is it should utilize the space. That is the foremost important thing. Why? Because we might be having a palletizing inventory or non-palletized inventory, but still we are supposed to utilize the space. This should not be an obstacle for the case of space utilization. So that is number 1. So maximizing storage density. So here obviously we are going to use some vertical high density storage layouts so that this can be used for the case of optimality. For optimal use of a warehouse space, yes, it is possible. And second case, improving inventory management. So this is another crucial task, because in earlier presentations we discussed that real-time data tracking is quite interesting part. Okay, so that real-time activity, how and hardware will assist, that is the crucial point here. Okay, so how and hardware will help us to get this particular task. So ASRS will do the thing. So real time computer controlled operations reduce inventory errors and enhance tracking accuracy. So this is how it is going to work. So the next case is increasing operational efficiency. So as the main principle of automation goes, so automation reduces the time required for storage and retrieval, speeding up order fulfillment. So these all are the objectives. So coming for the secondary objectives, that is advantages. Reducing labor cost. So obviously the need for manual, that is manual over exertion, is going to be one of the challenging part in a warehouse, where beyond one's ability to lift, still they work that particular task. So that particular work can be minimized on a greater scale. Enhancing safety. So ASRS minimizes human movement in potentially hazardous environment. Okay, so those cases it enhances the safety. So supporting just-in-time concepts. So within least possible time when you want the product to be picked and packed. So when you want to go ahead with JIT activities, JIT activities, yes, ASRS is going to ensure 100% support with respect to production scheduling and material flow. Key components. Now we'll see. So we just discussed about what is ASRS. Then the next discussion was with respect to the advantages and benefits what we can potentially gain out of ASRS. Now we'll see what all are the key components. So these all are the key components available in ASRS. So first is storage structure. So we should have a structure that is going to act as an housing. It is going to accommodate all the tools or the products what we can go ahead with. So usually it might be a rack, it can be shelves, customized pallets and bins. Directly we can accommodate the pallets or bins or cases, or even we can go ahead with some carousels. Trays likewise we can go ahead with. Then retrieval mechanism. So there are racks or shelves are there. So each one will be designated with some sort of identification mechanism. So there are some 10 racks are there, let us assume. So we should have a retrieval mechanism. You go to the controller and you call one particular rack. Rack number 10 means, so that should rotate or revolve, or it should have some movement, so that automatically whatever the rack we have called for should come to one particular position. Okay, that's the point where we can take the things out. Okay, so that is going to be the retrieval mechanism. We can think of retrieval mechanism in such a way. So first is the entire structure, a skeleton, and second case is retrieval mechanism. The third is input and output stations. See, obviously you have got a rack. Loading and unloading should not be in the same case, in the same space. The reason is efficiency. Okay, it should be different and output should be different, so that we should plan properly. And another thing is, earlier we discussed ergonomic window, the term ergonomic window. So ergonomic window is for an average human height, the distance between, or from the ground, the distance between waist to chest. So this particular portion is called as ergonomic window. So in a standstill condition, they will be able to access the product without much difficulties. They need not to bend, or they need not to be put some sort of extra efforts to put somewhere beyond one's average height. So ergonomic window case we can go ahead with. Then the next case is control system software. Obviously, when we have a controller, when we have a control system, there should be an interface between the hardware versus software. So how to control it? So that we'll have. And the other important thing is conveyors or handling equipments. Okay. So from the ASRS, manually we may not be in a position to pick it up. We might be depending on some conveyors, some tortoise shuttle, something like that. So it should communicate with it, okay, with the material handling systems what we have. The ASRS technology on the market handle different volumes, types, velocities, and non-palletized inventory what we saw earlier. Now, the main thing is there are 7 technologies are there in order to do this particular task. So ASRS, automated storage, we just saw the structure is going to be there, then retrieval mechanism. So based on this combination, we have got some 7 major technologies and we'll see one by one. So the first is going to be vertical carousel modules, VCMS, vertical carousel modules. Second, horizontal carousel modules, HCMs, vertical lift modules, VLMS, crane based mini load, ASRS, vertical buffer modules, so robotic cube based, and the last floor based AGVs or AMR based. So these all are the 7 different types what we have. So now we'll discuss everything in detail. So first, vertical carousel. So how the term vertical point has been coined is the arrangement of the structures. We have got the structure and that structure is going to be in the vertical case. So it is going to be in the vertical case. So there are going to be 2 pillars. We can have shelves or racks however the way we want, and we can provide a delivery mechanism and that is going to work. Here what is the advantage as well as that itself is going to be disadvantages. Upon one direction it is going to obey gravity. So from top to bottom when it comes, gravitational pull is going to be there. So that is going to take care of unloading. Okay. On the contrary, when you want to go against the gravity, defy gravity, so that is going to be another disadvantage. So while loading it is going to be a disadvantage, while unloading as due to gravity we can get it faster done. So this is what the easiest way, and this is the most commonly found ASRS system. VCM module is found almost all cases of complicated applications. So this is how it looks. So height, so volumetric utilization is going to be possible right from floor till the roof of the warehouse where we are, and it is rigidly mounted to the wall, so therefore safety is ensured. It is completely closed. Here for the case of image it has been cut out, but actually it will be completely closed, and ergonomic window is going to help us to take the product in a very easy case. Okay, so here you can see one particular case when you want to unload, gravity is going to be obeyed. On the contrary, it is going to defy gravity. So it is going to obey camouflaging part. One part it is going to be advantageous, on the counter when you see it is going to be a disadvantage. Horizontal carousel. So again same based on the earlier orientation. So on the premier case, former case where we saw it was in the vertical, but now it is going to be in the horizontal. So highly dense storage bins mounted on an oval track which rotates horizontally. So it is going to go horizontal. Earlier case it was vertical like this. Okay, now it is going to be horizontal. So upon understanding the orientation itself, we can come out with one outcome, that is horizontal means we can load heavier components, bulkier components, because the load is not going to be bared by the structures what we provide on the either end. In the case of vertical, it is horizontal, so everything is mounted on the floor, so it is going to go like this. Okay, so therefore the load is going to be borne by the ground surface. Okay, so this is how the structure is. So likewise it can go in a oval shape or an elliptical shape, even circular, well and good, but why don't you go for circular is inside the circle you are going to waste the space, so therefore oblong is always found to be the best. Okay, same ergonomic window concept, everything is there, but the only drawback is volumetric has to be thought of. Space wise it is okay, we may not be able to stack a little bit high, because again human should climb in order to take the product out. So that might be one particular area where we can improve. Next, vertical lift. So first case it was vertical and this is also vertical. But here what is the thing is, we'll have a lift mechanism. So that moves from one point to another in a staggered case. So that is going to be the advantage. Okay. So earlier case it was continuous, but here no, only in one direction it goes and other direction it comes. The way how a lift operates in an apartment building or so. So there are some 4 floors are there. This lifts right from ground floor 1, 2, 3, 4 it goes and again it comes back like this. So there is no continuous rotation, only reciprocating. So it goes to the top, comes down, top, down, likewise. But in the first case, vertical carousel, it is going to completely go like a giant wheel. Clear? Here it is not going to be so. It is just a lift up and down. So that is the difference. And here the same advantages as a VCM concept. Here it is reserved. But only thing is, here it is not going to completely make rotation. So here we are utilizing gravity as well as we are defying gravity. So that part is going to be little bit interesting. The next, from the thing you'll be able to get, so it is a crane based mini load ASRS. The same earlier, but the thing is on one end we'll have a crane. So on an average, human might be some 6 feet of height. Okay, on an average I am talking, maybe even lesser than that. So only human will be able to take in an ergonomic case only till 5 or 5.5 feet. That is the possible thing. But the objective of warehousing automation is to utilize this floor space completely. So volumetric we need to think of. So for higher end cases where the component or the product is positioned on the top case, so how to lift it? So crane based mini loading system. So a platform will be there, a shuttle based. So it is going to take even in the higher region, it is going to lift and it is going to bring it back. So it is a crane based mini load ASRS. So vertical buffer modules. So VBMs. So what is this vertical is? It's very simple. So same everything vertical case everything. But here you will not be able to access everywhere. Only in the prescribed part we will be able to take it out. So usually here either side that is this side will have a vertical buffer, this side will have a vertical wrench and in between tortoise shuttles will be there. So tortoise shuttles earlier we saw 2 entries and 2 exits. So that moves in a very faster case and that brings the product out. So usually it will be completely confined. 100% it is confined. So product will be pushed from that particular position and this tortoise shuttle goes and lift the product and it comes to the end user. So ergonomic window everything is maintained. But in between the product is going to be brought by the tortoise shuttles. So robotic cube storage. See, one simple example before we go for robotic cube storage, it is like this. See, two-wheelers or four-wheelers, we just park it in a very common case. So let us think in a non-valet parking case. So what happens is on the ground, we just park the cars. So the volume is going to be free. So think in case of valet parking. So there are racks over there. So one car is going to come to the ground. So obviously that will be elevated. Likewise, we can go ahead. So robotic cubic storage is of that nature where we are going to use completely smart robots we are going to use and there will be workstations will be there. So completely cluster of racks. Okay. So with the help of diagram, we'll be able to understand in a much better case. So this is how it's going to work. So here you can see, so it is usually not preferred for bulkier products, small products. So it is completely a cage like structure. So upon you select one particular product from its position, it directly comes out. Thanks to the smart robots available here. So it is completely a closed packed one. So robotic shuttles play a crucial role. So it's a GTP concept, but the thing is from the bulkier cube storage, robots are going to pick and place the product in the ergonomic window. Okay, and these things are quite hi-fi. It has not found its place in a common industrial point of view, but these are evolving techniques. And next, so swarm of robots, swarm, multi robots. Okay, robots will be used, floor robots will be used. So usually it is of AMR category. AGV means it's going to be complicated, but still AGV can be used for the case of wherever we find investment is going to be a tough task, we can prefer AGV sales. AMRs are preferred. So now what happens is this moves to one particular point inside the racks and it picks the product out. So usually they are called as a fleet of smart robots. So this floor robots goes to the point, picks the pot, and then they come out. So before we close down this, to summarize, so we have got a different automatic mechanisms in which ASRS is one particular category where it is going to help us to retrieve as well as to pick or place the component in a least possible time. So based on the configuration, we saw the different types of mechanisms to do this ASRS task. So with this, we finish this chapter. So any doubts, students, please note it down. We'll discuss in the offline class. So thank you, one and all. Thank you.